Hi, my name's Gabe. For this problem, we're asked to convert these two angles from radians to degrees.
I was just looking for the sports channel, Gary.
Welcome to 3-1, Day 2. And before we start this lesson, let's do a little flashback to shifting graphs. If we had y equals x squared, that would be a parabola opening up, and it would be centered at the origin like this. Now, we've got a couple maneuvers down here. Notice, and this is an x minus 3, and we're doing that before we square it. And then we have a plus 4 after the fact. If you remember back to, I think it was chapter 2, if we're messing around in here, that is a left-right shift. And I say it's kind of counterintuitive. If that's a minus, you're going to move it to the plus side. If that was a plus, you'd move it to the minus side. What we have going on out here after the squaring is done would be an up or down shift. And this one does make intuitive sense. Positive is a shift up. Negative is a shift down. The graphs that we saw in the last video, the exponential functions, will have similar shifts and maneuvers on their graphs. So here in example 5, it says each of the following graphs is the transformation of 3 to the x power, and we're just going to state which way and how far it's moved. So here's 3 to the x. Now we've got 3 to the x plus 1. This is similar to what's going on in here. We're messing around with the x variable before the operation, so this is going to be a left or right shift, and it's going to be sort of counterintuitive. So that's an x plus 1 power. That's going to be a shift to the left 1 unit. All right, in the second one down here, they're calling this one h of x. The 3 to the x is still there. Now, after the fact, it's a minus 2, so that's going to be a shift down of 2 units. Up next now, let's look at the next two as sort of in unison. Here we got a negative out in front of the function, and then here we have a negation of just the exponent. The way I like to think about these, you've got y equals something going on over here, some function. You know, if this function is usually positive and you negate this side, that means you're negating all these positive numbers to become negative numbers. And that's what's going on here. 3 to the x, an exponential function, is always up in the top two quadrants, positive and increasing. If I put a negative in front of that, it moves all these negative numbers down into the, or it moves all the positive numbers down to the negative quadrants, 3 and 4. So this is a reflect over x. Reflect over the x-axis. And we saw this when we were graphing them. When we negated the exponent, remember graphically we went from an increasing exponential function to a decreasing exponential function. But we just shifted or reflected that over the y-axis. So if we negate the exponent, the operation here, that is a reflect over y, over the y-axis. All right, I think you got a practice problem here. Yep, similar to what we just did. Pause the video real quick and figure out if you know how these graphs have been shifted, and then fire it up and see if you got them right. All right, first one. We're up here in the exponent. It's a minus, so that's going to be a shift to the right 2 units. Here's our 4 to the x. We didn't mess with that, but after we're done with 4 to the x, it's a plus 3, so that's a shift up of 3 units. Okay, now here, careful, we got 2 going on. We've negated the exponent, so that's going to be a reflect over the y-axis. And then here we've got a minus 3, so that's going to be an also down 3 units. But remember, there is an order to these. If you remember from college algebra, maybe you heard the acronym high school RV. We got to do them in this order. So let's see, we have a vertical shift of down 3. That would be our last operation. So we're going to do our reflection first. We would take our 4 over x, or that was 4 to the negative x, so it would look like this. The first thing we would do is reflect it over the y-axis. So now it would look down here like this, going through 0, negative 1. And then we would shift that down 3 units. So our new y-intercept would be at y is -4. There we go. All right, up next is a very special exponential function. They call it the natural base, base e. E is a number a lot like pi. Pi is irrational, non-repeating, 3.14159, blah, 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 blah. E is kind of the same thing. It's approximate. I should add approximate with the pi too. But this is approximately 2.718281828 dot, dot, dot. It goes on forever just like pi, and it never repeats. Now, you might wonder why they call this the natural base. Well, if you take calculus next year, you will see that I like to call this the magical base. Base E has some magical properties when it comes to calculus, and I hope I see you in class next year to discover those. But the book says this is called the natural base. The function given by e to the x is the natural exponential function. Its graph is shown in the figure. And it's got some common properties. It goes through the same y-intercept 0, 1. But if we put in x as 1, we would have 1 comma, and then our y value would be e to the first. If we went up higher above x is 2, the point would be 2 comma e squared. And that would continue as we go up toward infinity. And as we head to the left of the y-axis, when our x value was negative 1, we would have e to the negative 1 as our y value, or 1 over e. Keep going to the left, we have negative 2 comma e to the negative second, or 1 over e squared. So it looks a lot like any other exponential, except the y values are different. They're irrational. But again, this natural base and the natural exponential function has some fantastic properties. We can do these on the calculator also. Most calculators will have a special key. Here's my laptop calculator. Notice down here we've got the ln. We'll see that in the next section, 3.2, when we do the inverses of exponentials. But if we hit the second function key, that ln turns into e to the x. So what we would do for this is type in our exponent and then do an e to the x, or a base e of it. So here in our first one, we want to do x is negative 2. So I'm going to type in 2, make it negative, and hit e to the x. And then we have 0.1353. And there it is. E to the negative 1. I'm not going to type that in. You know, the steps would be the same. That should be 0.3678794. Here's one. It's a decimal, e to the 0.25 power. So I'm going to do 0.25, second function, e to the x, 1.2840. 1.2840. And then here we would do a negative on that, so negative 0.3 e to the x. Oops. 0.3, oops. 0.3 negative e to the x. 0.7408, and there it is. Here's a few for you to try. Pause the video, give them a try real quick, and see if you got them right. Let's see here. You didn't pause the video, did you? The first one, I got 1.34985, yada, yada, yada. For letter B, I got 0.3011942. And for the last one, 6.2. That's a big one, 492.7490411. And there we go, a little calculator fun. Now this one, I wasn't going to have you fill in all these and graph it to this precision. Here they want us to graph these two. In our first one, letter A, it's base 2, or it's 2 times e, and we've got a positive fractional exponent. In part B, we've got a 1/2 in front, and now our e is to a negative exponent. That right there is the biggest distinction between these. One has a positive exponent, one has a negative. And if we were going to go through and do the table, notice all the decimals they took this to. You know, I don't want to do that in this video or even in class, but it is nice to see a very well done graph of these natural base e exponential functions. So here's our first one. Again, you know, we usually go through 0, 1, but this had a 2 in front of that e. So that exponent would go to 0. We would have e to the 0 as 1, but times this 2, we now have a y-intercept of 2. When I drag down this other graph, we have a negative exponent, so that graph should be in a decreasing, you know, going from left to right. And it should not go through 1. It would go through half of 1 or a half. And there we go. We are going through a half because of that half in front of the base e. And our exponential function is decreasing as we go from left to right. And that's the end of this video. Sorry it was so short. We'll do some odd problems in class, and you can have a little fun on WebAssign.